Hi everyone, we are back with lesson 5, and this should be pretty much your last new lesson on probability. Today we're talking about the multiplication rule and computing probabilities and how we are going to use the multiplication rule to figure out if events are independent. So everything we've kind of seen so far has been, flipping one coin, picking one person, drawing one card. And that's going to bring us to multiple events today. So we do have this general rule for multiplication of events, which is the probability of A and B equals the probability of A times the probability of B given A. And yesterday we talked about independent events. So you see down here, when events are independent, the probability of B given A just equals the probability of B. Because if the probability of B equals the probability of B given A, then A and B had really no bearing on each other. So what they did, here's going to be pretty much the rule that you're most likely going to be using, that the probability of A and B equals the probability of A times the probability of B. And what they really did was just replace here the probability of B given A, knowing that if events are independent, that's really just equal to the probability of B. So probability of A times probability of B will give us that rule. Okay, so let's once again just start basic and we'll work our way up. So in this example, they're talking about a bag. It has 10 blue, 3 red, 2 white marbles. Mike shakes the bag, really good. Okay, so they want you to round all your answers to the nearest percent. So they want you to find the probability. Okay, so it says find the probability of drawing a red marble, replacing it. That's important. He puts it back and then draws a blue. So you're looking for the probability of red and then blue. Okay, well, your probability of red is 3 out of 15 times your probability that you're going to pick a blue is 10 out of 15, okay, which will give you 30 out of 225. You could simplify, you'd get 0.133, right, repeating. They wanted this to the nearest percent, so your answer is 13%. Okay? Next, they want you to find the probability of drawing a red marble and then a blue marble, but without replacing. So now you're not putting it back in. So the probability of red and blue, okay, but now things are going to change a little. Your probability of picking that first red is still 3 out of 15. So you're starting fresh, totally new question, but now you pretty much are saying you have a red marble in your hand. Now you're about to pick that blue, and now you have a chance of 10 out of not 15 anymore, 14, okay? And when you multiply, you'd get, what's 15 times 14? So you would get 30 over 210, which is equal to 0.142, which is approximately 14%. Okay. In the next one, it says find the probability of drawing 2 red marbles in a row, once again, without replacement. So now you have the probability of red and red. Okay, so your probability of picking that first red is 3 out of 15. Now again, if you pick that and you still have it in your hands, you now have 2 out of 14 to potentially get another red. So that's 6 out of 210, which is 0.028, which is approximately, nearest percent, 3%. Okay. Last one says, find the probability of drawing 3 blue marbles in a row without replacement. Okay, so we need the probability of blue, and then blue, and then blue. Okay, so 10 out of 15 is my first shot. I'm still holding on to it. 9 over 14 times 8 over 13. Okay, so I'm going into GeoGebra for this one. I'm going to do my first fraction, which was 10/15. Ten over 15 times 9/14 times 8/13. Okay, so they give you 24 over 91, or 0.2637. I'll go with that. 0.2637, which is, to the nearest percent, 26%. Okay, so those were, again, starting out simple, pulling and doing basic probabilities with and without replacing. Okay, so again, you have an end, you're multiplying your probabilities. Okay, so let's take a look at number 2. Two drugs operate independently of each other. Okay, so this is important, independently of each other. So one does not affect the other. Drug A is effective 90% of the time. Drug B is effective 80% of the time. If both drugs are administered at the same time, find the probability that neither drug is effective. Okay, so let's talk about this. If neither drug is effective, then you don't really care about when drug A is effective. You care when it's not effective. So what's the probability of A not effective? So not A. Well, if the probability that it's effective is 90%, it's got to be 10%, and they're complements of each other. So it's 1 minus 0.9, right? Your full probability would be 100%. So to find a complement, you do 1 minus the effectiveness, which would be 0.1 or 10%. So we also need the probability of not B, right? That neither drug is effective. So once again, you're going to do your complement. 1 minus 0.8 would give us 0.2. So the probability of not A and not B would be 0.1 times 0.2, which gives you 0.02. That should be your answer. Your probability that neither one is effective, that's just working with complement. Okay? Okay. So your multiplication rule also serves as another way to check independence, okay, which is really nice. Events A and B are independent if the probability of A and the probability of B is equal to the probability of A times the probability of B. So it's definitely not the definition. Like, do you remember yesterday we talked about the probability and the definition, which you see back over here? Okay, here's your definition of independence. That's how you that's how they define it. The probability of B given A equals the probability of B, meaning A did not affect that probability of B. But this is another definite way to check independence, and we see this a lot with the regents in different questions. So let's talk about this one. In example 3, they say, given events A and B such that the probability of A is 0.5, the probability of B is 0.4, and then they give you your or statement, the probability of A or B. Okay, remember your or looks like that. So A or B is 0.8. Determine whether A and B are independent or dependent. So in order for us to know if they're independent or dependent, we need the end statement, okay? We need the end. Look up here. So to test whether they're independent, we need this. In order to get that, we can use our OR formula. It's a couple of days ago, so remember that your probability of A or B, you'll remember this when I write it, is the probability of A plus the probability of B minus the probability of the overlap, A and B. Okay, do you remember that? So if we now know 3 out of the 4, we could solve to get, this is what we want. We want A and B. This is the one we're solving for. So the probability of A or B here is 0.8. The probability of A is 0.5. Probability of B is 0.4. And we are now going to find the probability of A and B. So I like to move the probability of A and B to the other side because you see how this is negative. If I move it to the other side here, I now can solve for the probability of A and B. And that would be 0.5 plus 0.4 minus 0.8 because I'm going to move this guy to this side, but I'm going to move the 0.8 to the other side. So the probability of A and B would equal 0.1. Okay, so now that I know A and B, probability of A and B equals 0.1, I can do an independence test. I could use that formula up top and say, okay, is the probability of A and B equal to, question mark, the probability of A times the probability of B? Well, we just figured out that the probability of A and B is 0.1. Is that equal to the probability of A, 0.5, times B, 0.4? And 0.1 is not equal to 0.2. So you would say, you could either say they are, I would just say, instead of they are not independent, they say independent or dependent, I would say they are dependent. Okay, they are clearly dependent. They don't equal. They are independent if the probability of A and B equals probability of A times probability of B. Okay, it's a lot of work. All right, so now let's try the next one. So in example number 4, they say a student is chosen at random from the University of Phoenix. Okay, the probability that a student takes a math course, okay, so they take a math course is 0.5, half, 50%. The probability that they take a science class is 30%. And the probability that they take a science class or a math class. Okay, so I'm just going to write out these little probabilities. We know that the probability that they take math is 0.5. The probability that they take science is 0.3. And the probability that they take math or science, you could use that or, equals 0.65. Okay, so that's just our given info. They want you to find the probability that a student takes both math and science. Math and science. So that's very similar to what we just did, okay? So how do we get that? We know that the probability of math or science is equal to the probability of math plus the probability of science minus the probability of math and science. Okay, so our OR is 0.65. Our math is 50%. Our science is 0.3 or 30%. Okay, we could even make this an X. I know a lot of people like to do that. That's what you're figuring out. That's okay as well. So once again, if I bring the X to this side, then I know that's 0.5 plus 0.3 minus 0.65. Okay, so that's 0.8 minus 0.65. So I now can say that the probability of math and science equals 0.15 or 15%. Okay? Again, you could use the X, you could use probability in math and science, whatever you want to do. You could use the symbol, you could use the words. Okay, so the events takes a math class, takes a science class. Are they independent? Explain. Okay, so we have to test for independence. Using what we just found in part A, we could test. We could figure out, is the probability of math and science equal, I'm going to put a little question mark, to the probability of math times the probability of science. Okay, so probability of math and science is 15%. Probability of math is 50%. And science is 30%. And 0.15 does equal 0.15. Okay, so yes, they are independent. They are independent simply because the probability of math and science equals probability of math times probability of science. As easy as that. That's how you're going to explain. Are the events takes a math class and takes a science class mutually exclusive? No. We know that because the probability of them both happening is not 0. So I would say no. The events share outcomes and can happen at the same time. They are not mutually exclusive. Okay? They're not mutually exclusive. They literally, the probability of math and science isn't 0, which means, right, this is how we said they're not mutually exclusive. Probability of math and science doesn't equal 0. Okay? So that makes them, they are not mutually exclusive. All right, so we're good. So I gave you, let's see, 1, 2, 3, 4, 5. There's 5 homework questions. You guys can practice. And that's it. I will see you next week. Just no, this is the last one. We're going to do a bunch of review days, and then I think you'll have a graded assignment by mid-week next week. That'll be due next Monday. So this is it. We are going to be finishing up our second to last topic and moving on to statistics. So crazy. Okay, have a great